We're solving problem 22 from the 2022 F equals MA exam B. A cannon just above the surface of a spherical planet with mass m and radius r launches a particle with speed v, where the square root of gm over r is less than v is less than the square root of 2gm over r. The initial velocity of the particle makes an angle theta with the vertical direction. Neglect drag. For what theta will the particle never collide with the planet? So, in this problem, first thing you want to notice is that, well, obviously the radius is r and the masses of the planet is m. Now, the bounds of this velocity of the object being launched into the space, since it's between these two seemingly discrete values, well, these are actually very important values in physics. The square root of gm over r is the velocity needed for an object to stay in a circular orbit. And the square root of 2gm over r is the velocity needed to escape the orbit. So, in this case, escape the orbit of this planet. Now, since we want it to, it's gonna never collide with the planet, and it's not gonna escape the orbit of the planet. So that means, well, it's not in a circular orbit, but it's not gonna escape too. That means there's gonna be a slight variation, a slight bulge. So, its orbit is going to be in a sort of elliptical shape, like this. Now we just need to find a place to launch it from, you know? And in physics, well, in this case, the best case, or the only way to launch it is when you do it exactly 90 degrees to the vertical. So you have a 90-degree angle here, and you have the projectile, and you're launching it 90 degrees into space. Like if you draw an ellipse around it and it's like 90 degrees, it will never hit the planet if the velocity is always perpendicular to the centripetal force. So for this problem, our answer is only at theta equals 90 degrees. Otherwise, it will always hit the planet. So that's your answer.